Good morning, sir. This is Nivir Mohanto from the Department of Information Technology, and today I'm going to explain Taylor series and Maclaurin series. First of all, let's have a look at the Taylor's theorem. The Taylor's theorem is a fundamental concept in calculus that provides an approximation of a function near a point using polynomials. Specifically, it expresses a function as an infinite sum of terms calculated from the function's derivatives at a single point. We can see the Taylor's theorem that goes like f of a plus h is equal to f of a plus h f dash of a plus h squared by 2 factorial f double dash of a, and it goes all its way till its nth term, that is h to the power n divided by n factorial and multiplied by the nth derivative of the function a. F dash, f double dash, and fn are the first, second, and the nth derivative of the function. Now, here we get an important equation, that is h is equal to x minus a. Here in this equation, a is the point of expansion around which we are approximating the function. So basically, this is the point that we know the function of and we can easily derive it. X is a point of interest at what we want to evaluate the function using the Taylor's expansion. This is the point of interest where we want to evaluate the function using the Taylor's expansion. And h is basically the small difference between a and x. Now, if we tend the n to infinity, it's called the Taylor's series. The Taylor's series is an infinite series representation of a function where the function is expressed as a sum of terms based on its derivative at a single point. The series approximates the function near a point. Now, it goes like f of a plus h is equal to f of a plus h f dash of a plus h squared by 2 factorial f double dash of a, and it goes all its way till infinity. Now, if we put h is equal to x minus a, we get the Taylor series expansion about x is equal to a. Now, in this equation, we can see that we have substituted the value of h, that is x minus a, in the above equation that we have got. And now, it goes like f of x is equal to f of a plus x minus a f dash of a plus x minus a whole squared 2 factorial f double dash of a, and it goes all its way till infinity. Now, let us move towards Maclaurin's theorem. Now, in the Taylor theorem, if I put a is equal to 0 and h is equal to x, we get the Maclaurin's theorem. Now, the Maclaurin's theorem goes like f of x is equal to f of 0 plus x f dash of 0 plus x squared divided by 2 factorial f double dash of 0, and it goes all its way till the nth term, that is x to the power n divided by n factorial f n of 0, that is the nth derivative of the function 0. Now, if n tends to infinity, it's called series. We got it like in the previous series. The Maclaurin series is a special case of the Taylor series. It's a special case of the Taylor series expansion of a function around the point x equal to o. It represents the function as an infinite sum of terms calculated from the value of its derivative at x equal to 0. So f of x is equal to f of 0 plus x f dash of 0 plus x squared divided by 2 factorial f double dash of 0, and it goes all its way till infinity. Now, let us try to solve some questions. So, in this question, it has been given that find the Taylor series expansion for a function f of x is equal to x squared at x is equal to 1. So, we know that the Taylor series expansion of a function f of x about x is equal to a is given by this particular series. So first of all, let us write the function. So the function is f of x is equal to x squared. Now let us find the derivatives of it, that is twice of x, 2 and 0. Now instead of x, if we put 1, because x was equal to 1, f of 1 is equal to x squared, that is 1, f dash of 1 will be 2, f double dash of 1 will be 2 as well, f triple dash of 1 will be equal to 0. So now let us put this in this series, and also let us remember that as it's a Taylor series expansion of a function about x equal to a, therefore a will be equal to 1 as well. Now let us put the values in this function. F of x is equal to f of a plus x minus a, f dash of a plus x minus a whole square 2 factorial f double dash of a, and we don't need to find this term because f triple dash of a is equal to 0, so it's going to be 0 as well. So let us just place plus 0. So now f of a, that is f of 1, is equal to 1 plus x minus 1, and f dash of a is equal to 2 plus x minus a whole square, that is x minus 1 whole square divided by 2, and it will be multiplied by 2 as well. So now if you find this out, x square plus 1 minus twice x. So twice x should be cancelled. 1 plus 1 is equal to 2, 2 minus 2 plus x square, that will be equal to x square. So this is the value of our question. This is the answer of our question. So let us now move towards the other question that is related to the Maclaurin series. So we have been given to expand a simple function, that is sin x, using the Maclaurin series. So let us try this question. So first of all, we will get f of x, that is equal to sin x, f dash of x, which is equal to cos x, f double dash of x, which will be equal to minus sin x, f triple dash of x, which will be equal to minus cos x, f to the fourth derivative, let's find it out, it should be equal to sin x again, and f to the fifth derivative, f of x to the fifth derivative, it should be equal to cos x again. So now we know that it's a Maclaurin series, so we should be aware about the fact that instead of x we should take 0, so it should be f of 0. So let us find out for the f of 0 term. So f of 0 and sin x, that is sin 0, is equal to 0, and f dash of x, that is cos 0, is equal to 1. So f double dash of x, that is minus sin 0, which will be equal to 0 again, f triple dash of x, which will be equal to minus cos 0, which will be equal to minus 1, f5 of x, f4 of x is equal to sin 0, which will be equal to 0 again, and f to the fifth derivative, it should be equal to cos 0, which should be equal to 1 again. So now let us try to solve this question. So we know that f of x is equal to f of 0 plus x f dash of 0 plus x square 2 factorial f double dash of 0 plus x cube 3 factorial f triple dash of 0 plus x to the power 4 factorial f fourth derivative of 0 plus x to the power 5 fifth factorial f and fifth derivative of 0 all its way till infinity. So now let us try to find the values of which 0. Let's find the values of the derivative of which the value is 0. So f of 0 is 0. F double dash of x is 0. F to the fourth derivative is equal to 0. And we got remained with the first derivative, the third derivative, and the fifth derivative. So let us keep it that way. Like, let us keep it x should be equal to x into 1, x cubed by 3 factorial, and this should be again equal to x to the power 5 by 5 factorial, and it will go all its way till infinity. So let us just simplify this question. X into 1 will be equal to x minus x cubed by 3 factorial will be equal to 6, and x to the power 5 by 5 factorial should be equal to, I guess it should be equal to 120, and it will go all its way till infinity. So this was my explanation for Taylor's and Maclaurin series. Hope you like it. Now I'm going to wrap up this explanation video. Thank you so much.